You know, I grew up in country like this. My dad and I would ride our horses up to these amazing high mountain lakes. We'd ride back into some pretty remote wilderness areas with incredible streams and meadows and wildlife. I love it here. Look at this canyon. It reminds me of the Grand Canyon. You got this little stream, you got these steep canyon walls. How long do you suppose it would take for a stream this small to remove this much material and cut the canyon this deep? This rock has a history, just like I do and just like you do. It came from somewhere. A lot of these rocks have been dated to be 350,000 years old, up to 2 million. That's pretty old. But it might surprise you to know that all of the geological formations that we see here, the canyons, the layers, even the plants, are younger than I am. When I was born, there was nothing here but a vast forest, hundreds of feet below where we're standing right now. In fact, before 1980, most people had never even heard of Mount St. Helens. It was in that year, on May the 18th, that molten rock created a steam blast with a force of 20 million tons of TNT. Avalanche debris and other flows from the eruption laid down all of those layers rapidly, up to 600 feet thick. A couple years later, there was some more volcanic activity that created a mud flow that cut out this entire canyon. It also cut through deep bedrock, all in a couple days. Isn't it amazing what a little bit of information from the past can do to help change your view of the present and the present world around you? There are a lot of assumptions made by a lot of people about the history of the earth around us. The question is, how do those assumptions affect how we view that history? But more importantly, how do they play into how we view science and the Bible? Did God create the world in a few days or billions of years? Is mankind descended from apes, or did God create us instantly in his image? Was there a global flood that destroyed the earth, or is that a myth? In other words, is Genesis history?
When we think about the history of the Earth, there are a lot of things we need to consider. But one of the most fascinating is the account of the flood. Was the whole Earth covered with water? Genesis says the waters prevailed so mightily on the earth that all the high mountains under the whole heaven were covered. So if the flood was truly global, wouldn't there be a lot of evidence? I'd heard of a scientist who had spent over 40 years studying this question. When I spoke to him, he said he had a great place where we could see evidence for the global flood.
Steve, I gotta admit, I've been here several times, but every time I come here, it is breathtaking.
Besides being at home, Grand Canyon is my favorite place on Earth.
Yeah. So, Steve, tell me, what do you see here?
When we look at Grand Canyon, we see the inside story to the ground beneath our feet. And we kind of have a layer cake here, don't we, of strata that have been eroded for our benefit to see the inside structure of the Earth. These same layers are also in Colorado. We're also in Illinois, also in Pennsylvania.
So when you say sedimentary strata, you're talking about the layers that we see?
Yes. So the lowest layers are formed first. Those are sediment grains that were mixed, separated, and flowed in here from different directions and accumulated one on top of another. And then, of course, naturally, they convert to rock.
So you're saying that the solid ground we're standing on right now, if we went back in its history, it'd be liquid?
Yes. So the ocean is doing some amazing things, and water of incredible power is depositing the layers we see in the canyon.
And are there fossils in all of those layers?
There are marine fossils through all the layers. But the standard explanation is there were 17 different advances and retreats of the ocean over the North American continent, and it was extended over hundreds of millions of years.
And what is the evidence that you see here that would say that doesn't seem to make sense?
The 4,000 feet of flat-lying strata in the canyon are flat, and relative to one another, we look in between the strata layers and we don't see the passage of time in between layers.
You mean erosion?
Erosion, especially, and channeling on any great scale is not visible. And then we look at the strata themselves, and they provide evidence of rapid, very rapid sedimentation. Just minutes or hours is all that's needed to make layers.
Well, tell me about the story of these layers. I mean, how did they get here?
In the 600th year of Noah's life, on the second month, the 17th day of the month, the same day were all the fountains of the great deep broken up and the windows of heaven were opened. My understanding is the ocean floor upheaval occurred. Some type of magma or earthquake propelled the oceans over the continent.
So that's why we get these marine fossils in these layers.
Yes, and we have 6 months the waters prevailed upon the earth, another 7 months or so for the water to subside. The 4,000 feet of strata probably represents the early and middle part of the global flood right here in Grand Canyon. We have other strata locally in this Grand Canyon region. That's called the Grand Staircase. We have about 10,000 feet, 2 miles thickness of strata on top of the Grand Canyon.
Higher than where we are.
Higher than where we are, and that represents the later stages of the flood and the retreat of the floodwater. This surface was beveled by retreat of floodwaters, and as the flood retreated into the newly formed ocean basins, then the continents probably uplifted, and the ark, of course, was landed in the high country in the Middle East.
Well, there's some people who say that that record is about a local flood.
I believe it's a global flood, and all the high hills, or the whole heaven, were covered, a universal statement. But that mountains have risen since then, and we shouldn't measure the depth of the floodwaters by the present mountains of the earth, which are largely created during the flood and after the flood.
Well, the fact that we have all of these layers would be unknown to us if we were standing on them, you know, somewhere else, but they're known to us because they've been cut out. How did that happen?
Well, it was a story that we all learned in grammar school. Okay, Colorado River, over tens of millions of years, cut the Grand Canyon. Most geologists have jettisoned that idea. It's hard to sustain a canyon like this for tens of millions of years. You can't imagine a canyon enduring that long with erosion.
Is that because it would have eventually, the sides would have collapsed and broken down? Then how in the world do we get this all carved out?
Well, there are lots of theories, and personally, I like the idea of catastrophic erosion by drainage of lakes.
So after the flood, we have these large bodies of water, these lakes that are trapped.
There's evidence of the big lake in the Painted Desert, a place called Hopi Buttes, about 500 cubic miles of water in this huge lake.
And so the dam breaks, and all of that massive amount of water then is now pouring out and carving this.
Yes, and how long would it take to erode Grand Canyon? Maybe weeks, but not millions of years. Time is not a magic wand that solves all the geologic problems of the world. Jettison that way of thinking about millions of years and then start thinking about catastrophic process like you've seen at Mount St. Helens, and that'll help you understand Grand Canyon.
Everywhere we looked, Steve showed me evidence of the incredible power of moving water. It quickly laid down these enormous layers, then quickly eroded them away. Steve wanted to show me where the floodwaters first hit the continent, so he took me deeper into the canyon.
Steve, when you said you were going to bring me to the bottom, you weren't kidding, were you? We're at the bottom, aren't we?
So we're in this big side canyon to the main Grand Canyon, and we're looking at the granite basement rock, which is the core of the continent, if you will. And then we see the flat-lying strata on top of it. The boundary between the granite rock below and the Tapete sandstone above is this surface we call the Great Unconformity.
Why does it appear to be such a stark line? I mean, it's clear.
I think it's an erosional boundary of colossal scale. We're looking at something that shows the magnitude of flood flow over a surface.
And is it just here?
The Great Unconformity is continent-wide. I've seen it, I believe, in the Middle East. It's over in Europe. It's in Africa, and here it is under the North American continent.
So we've got this layer. How thick is this layer? What goes up from here?
Well, we have the Sauk mega sequence here, if you will, 1,000 feet of sandstone, shale, limestone that goes continent-wide. There are 4 other big sequence packages of strata that sit above it. Those are also very continuous like this. What we're seeing here is rather representative of the rest of the world.
It makes one really question the notion that this all happened because of a small local flood. We're talking about something enormous.
The power-moving water was beveling and pulverizing rock, depositing great thicknesses of layers and calling our minds to think about a global flood.
The conventional story is entirely different, though. It would say that there is a lot of time between each of these layers.
Some people have said that the Great Unconformity boundary here represents 500 million years.
You mean between the granite we see and that first layer of the sedimentary rock?
Yeah, they say that there may be 500 million years there, okay? And that's what their explanation of Earth history would ask them to consider. Yet when you come here and look at this, nearly a featureless plain. It's not exactly a plain, but it's a gently rolling surface. And would that be the product of billions of years? Or would that be the product of the power of water planing off a surface? Time is foreign to a good explanation here. And so we want to explain what we see. Everywhere we look, we see the power of water. And it's water on a colossal scale, and that's the story here in Grand Canyon. It's not a little water and a lot of time. It's a lot of water and a little time.
Time really is the central issue when talking about the history of the Earth. How much time did it take to form what we see around us? It seemed clear to me that a global flood would have transformed the Earth quickly. Yet I know many people think that the world formed slowly over billions of years. What was the real difference between these two views of time? I needed to talk to someone who could tell me more about science and history and time. Since my background is in computer science, we met at a place where I had personally experienced some of that history. As we looked at the exhibit, I was reminded how much smaller and more powerful computers have become since I first started using them. Paul said our changing assumptions about computers were really a series of paradigm shifts.
So when I was 19, I read Thomas Kuhn's classic, The Structure of Scientific Revolutions, where he describes this notion of paradigms. A paradigm is a framework within which you interpret evidence. So really, science isn't just about the evidence, it's about how you interpret that evidence. So this room, for example, we've got so-called mini computers here, but really they're not mini at all in terms of our current paradigm.
Yeah, today, right?
Yeah, this.
Yeah.
Right? So really, to understand this question of origins, you really need to begin by looking at the governing paradigms, the two major views that we currently have about the history of life and the history of the universe.
And what are those?
On the one hand, we have the conventional paradigm. In the conventional paradigm, you've got deep time, 13.7 billion years, along which this gradual process, beginning with primal simplicity, ending in what we see today. All the complexity in life has to be built bottom up by strictly physical processes where no mind, no creator, no design is present. The second view we can call, let's say, the historical Genesis paradigm. Everything starts with a divine mind, a creator, an intelligence that plans and superintends and brings into existence reality. Events are happening on a much more recent time scale. The universe, the solar system, our planet, life itself, all of that begins fully formed as a functioning system.
It's not hard to see there's a radical difference between those two in terms of time.
When we look at the history of life on this planet, we've got a body of data, but depending on the paradigm that one adopts, that data will be interpreted in very different ways.
It seems that one paradigm is drawing on a history that was given to us.
Yes.
And another paradigm is constructing that history. Is that how you see that?
We have a witness to those events, and that witness is telling us this is what happened, and we have to take that into consideration when we evaluate the data.
Well, Paul, the reason this becomes serious is that we're not talking about a history of just boiling water at a certain temperature. You know,
Right.
We're talking about a history that deals with the origin of the universe. It deals with the origin of life,
Yeah.
the origin of humanity, the origin of sin and why there's evil in the world, the origin of the geological formations that we have around us,
Yeah.
the origin of language. I mean, this is history that is not minor.
Yeah.
This is dealing with major, major elements of humanity and where we are.
Yeah, you're talking about the origin of literally everything. And I think if we zoom out from that and say, well, what really is the difference between these two paradigms? It isn't a question of science on the one hand versus religion on the other, because both of them are scientific in the sense of looking at a common body of data. Really, at the deepest level, the difference is two competing views of history. What is the true history of our cosmos?
That does seem to be the real question. What is our true history? What actually happened? The conflict is not between two views of science, but between two competing views of history. Since Genesis was written in Hebrew, I wanted to talk to a Hebrew expert. What was actually in the original text?
The first word in Genesis is Breshit. Breshit, Genesis 1:1 is Breshit bara Elohim et hashamayim ve'ha'aretz. So this is the beginning of the Toledot of Noah. Interesting that word Toledot is a very interesting word. It's translated sometimes genealogy, sometimes it's translated history. And what follows then is the account of the flood.
Mm-hmm. Steve, it seems that there is a lot of history in the Bible. Is that how you see it?
Oh, absolutely. In fact, the first thing is that it's an accurate historical account.
Mm-hmm.
The presentation is such, and the perspective of the writers, that they believe they were talking about real events.
Okay.
It's very obvious that because of the way in which they insist that the next generation learn their history.
When you look at these early chapters in Genesis, what do you see? Can you take us through this?
It starts with, in the beginning, God created the heaven and the earth. There's no word in Hebrew for universe. That means he created everything. Mm-hmm. And then the next thing we find in Genesis 1:2, we find a water ball that is in space. Mm-hmm. God, in the subsequent days, is going to fill that universe.
Well, you're talking about days here. Do you see these as literal days? Is that what the text is telling us? Or you know what other people think, that this is just a poetic, different
Well, first of all, it's not poetry. The world's greatest Hebraists all affirm that this is a narrative. Mm-hmm. They say that that's one of the unique features of the Genesis accounts of creation and the flood, is that they are narratives, because in the ancient Near East, they are done in epic poetry, which is very different. And here we have narrative to indicate that this is historical. What that means is that you should understand the words, the normal way in which those Hebrew words are understood. The word yom, it means day. The foundation of its usage is what we mean by a day. It's a 24-hour day. The only way you'd want it to mean a longer period of time is if you impose an alien concept to the text and say, well, I think that these are ages, and therefore yom has to mean ages. What you have to do is start with the text.
Yeah.
If we start with the text, yom means day.
So when we come to the passage that talks about the creation of Adam and Eve, you're seeing that as a clear historical event which would stand in direct opposition to the conventional paradigm that man evolved out of a long, long process.
The biblical text is not compatible with the standard, the conventional paradigm. The Bible teaches that the Lord God formed man, artistically breathed in him the breath of life, created him in his image. And then, of course, woman is created. We have marriage. We have the fall. Then in Noah's genealogy, we have the entire flood account. And the flood, is it a global flood? Well, I mean, I don't know how many times. I think 35 times or so the word kol, which is all, occurs in the flood narrative. If this is a judgment on mankind, then it has to be global. We continue through these first 11 chapters of Genesis. We come to chapter 10, which is called the Table of the Nations, which are the sons of Noah. It mentions in that chapter that the people are in their different nations and their languages. So Moses goes back in Genesis 11, 1 through 9, and explains how the languages develop. And so we come to the Toledot of Terah. And the Toledot of Terah is not going to be about Terah. It's going to be about his famous son, Abraham.
It just seems so apparent that there's no disconnect between all of that and everything that we see in the beginning. It's just one long historical narrative, is it not?
It is. As a matter of fact, the genealogies form the structure, not just for Genesis, but the narratives are embedded in the genealogies. The genealogies are picked up, that's actually called the Toledot, in the book of Ruth, to establish that David is a descendant of Judah, which is required by Jacob's prophecy. And then we move into the New Testament. How is the pedigree of Jesus established? With two genealogy, one going back through Mary's line, all the way back to Adam.
Steve, in light of all of this that we have seen, how important is the historical narrative that we find throughout Genesis, including all of the generations that are laid out there? How important is that to Christianity?
It shows that Christianity has a historical basis. It's what the Scriptures say, and the Scriptures represent actual historical data. So Christianity it's not a leap in the dark. It is understanding that it has a very strong historical basis, and that our Savior is also our Creator.
These genealogies are incredibly important. If Jesus is descended from Adam, and Adam was created on the sixth day of creation, then the earth can't be very old. So where do the millions of years come from? I met a geologist at a place where he said we could understand this better.
You see the quietness, the expanse, nothing to disturb you. Yet you've got the reminder that it was explosive in the past. There was this volcano back here, this cinder cone volcano, and it belched out this lava flow that spilled out across this countryside.
Just a huge amount of basalt, lava.
Yeah, but it's actually small compared to the lava flows that we see in many places. And there's something like 1,000 of these volcanoes around here. And the little one behind us here, we call that a cinder cone volcano.
You call that a little one?
Yeah, well, it is. I mean, these volcanoes are small. Mount St. Helens, 1980, when it erupted, okay? The top 2,500 feet of the volcano blew off, but that was small compared to historical eruptions. We can go back a little bit further to the Great Yellowstone eruption, and some of the volcanic ash was down in Texas. It blew that far away. You think about lava flows in India, that you have an accumulation of up to 1,000 feet over an area a third of the size of the subcontinent of India. What we see in the present is really only minuscule by comparison to what we've seen in the past. And that's telling us something about the historic past. We can't use present-day rates of these processes to understand how quickly and how majestically, in terms of scale, the geological record accumulated.
Well, that is the point that has brought me to you, because how do we determine the age of these rocks?
Well, the important first thing is to recognise that this lava flow is, in a sense, an instant in time. It's an event. And when it's molten, you've got all the different elements that have come out of the volcano are all mixed up, and the rock starts to crystallise. Any of those atoms that are radioactive, they now start to accumulate what we call the daughter products, the decay products. Now, the point is that this rate of decay is so slow when we measure it in the present that, it takes millions of years for parent atoms to decay to daughter atoms. And so that's ultimately where the millions of years come from, the fact that the decay rates in the present are slow.
But we would say that the present is not really the key to the past, because obviously the past holds some massive, massive catastrophic events that are not going on today.
In fact, the Bible would say that the past is the key to the present. If you want to understand why the way the world is today, you've got to understand what happened in the past. So we've got lots of hints that geological processes haven't been at constant rates through time, and we have other hints that the decay rates may not have been constant. See, we've taken rock samples from a number of places, lots of samples in the Grand Canyon, each of these rock layers. I've done it in New Zealand. We've done it in other parts of the world. And what we've done is we've submitted the same samples to more than one of these dating methods. And so what we found is on the same samples with more than one method, we were getting ages that were different by hundreds of millions of years or even a billion years in some instances. We're seeing huge differences by using different methods.
Well, if there is that kind of a difference between all of these dating methods, then that would seem to confirm the fact that we have an open system here, not a closed one.
And if we have an open system, that means we can't trust it to give us dependable dates for these rocks. And that changes the whole thinking about the history of the Earth, because suddenly now these radioactive clocks are not reliable. We've got evidence that rates were faster in the past. Suddenly, we may not be thinking in terms of millions of years. We may be thinking in terms of a history that is much shorter.
But you were saying that this kind of evidence is in the open literature now.
Yes.
Why is it not making an impact?
Well, I've been asked that when I've spoken in university geology departments. And the answer is because there is a commitment to the millions of years. And so once people get locked into that focus, anything outside their field of view that conflicts with that focus is marginalised. And the reason why the millions of years are important, if we go back in the history of scientific thought, Charles Lyell in England proposed millions of years, and they multiplied the ages for the rocks. And that was the foundation on which Charles Darwin built. In fact, he read Charles Lyell's book and was convinced of the millions of years of geological evolution, so he could say, now, given enough time, what we don't see happening in the present, we might only see small changes in the present. Given millions of years, the small changes can add up to big changes. And so if you want to have a way of looking at the history that says that we got here by chance, random processes over millions of years, then you've got to have rocks that are millions of years old. Otherwise, you've undermined that whole foundation of that view of Earth history.
So time becomes the critical element for the conventional paradigm.
Exactly.
And that time has to be deep time.
Andrew said when you study the rock formations, they show evidence of a young Earth transformed by a global catastrophe. So he took me south to Sedona to see it for myself.
The important thing to note is that this landscape is actually very stable. There was lots of erosion in the past to carve out this whole terrain, but those cliffs and the valley floor are very stable, which is why you've got the vegetation. Today, everything's much quieter. Today's processes are extremely slow, but they can't explain how we got this erosion, how we got these layers, how we got these cliffs.
All right, so you wanted to come here because you see evidence of a young Earth because of what's here. What do you see?
Yes, well, the first thing we notice is the extent of these layers. It's like a stack of pancakes. For example, the red unit that goes all the way across our field of view, that's the Schnebly Hill Formation. And above that, you can see the first white unit is the Coconino Sandstone. And above that, you've got the Turaweep, and at the horizon, you've got the Kaibab Limestone, which is the rim rock of the Grand Canyon. And, you know, here we are, 70 more miles from the Grand Canyon, and these layers are still here.
Yeah. It's almost hard to imagine the volume of material that represents.
Yes. Take the Coconino Sandstone. We can trace it from here, right across New Mexico, Colorado, right over towards Kansas and Oklahoma, or even in Texas. We're talking at least 200,000 square miles for this one rock unit that's consistent for mile after mile after mile. That's not the scale that we see today with localised sedimentation. And to get it flat-lying like this over such a large area, it's like you have to make your pancake all at once very rapidly. And so these layers show evidence of rapid sedimentation, the extent of these layers.
Well, Andrew, you were talking about that red formation, but that doesn't sound familiar to me.
No, that's the Schnebly Hill Formation. It's not in the Grand Canyon. In the Grand Canyon, we go from the Coconino into the Hermit Formation. There's that knife-edge boundary, and there's no evidence of erosion there, which means that the Hermit Formation was rapidly deposited, and then immediately the Coconino was a deposit on top of it. But here, we've come 70 miles from the Grand Canyon, and we've got this Schnebly Hill Formation between the Coconino and the Hermit. And this Schnebly Hill Formation, 800 to 1,000 feet thick, over an area of 1,000 square miles, had to have been formed very rapidly. If that took millions of years, we ought to see millions of years, evidence of millions of years erosion back in the Grand Canyon at that same boundary. We don't. So that means that this Schnebly Hill Formation in this area had to form in a matter of hours. So it tells you that not only is there a lack of erosion, but there's no time between those boundaries. So the whole sequence of layers was very rapidly deposited.
So we have this large extent of layers. We have the lack of erosion between the layers. What other evidence do you see?
Well, if we look closely, for example, at the Coconino Sandstone, we see the bedding, that there's bands within it that are sloping. We call those cross beds. What they indicate is that you had underwater sand waves were moving along. The comparison is in a desert. It's important to recognise that there's a difference in the angle in a desert dune. It's usually 30 to 34 degrees of these sloping beds. Underwater, it's usually 25 degrees or less. And Dr. John Whitmore has combed the hills around here with his students, hundreds and hundreds of measurements of these cross beds. And they all come in the range of 15 to 25 degrees. So it was underwater deposition. And so these layers are accumulating in hours, weeks, and within months, you've got this whole stack of pancake layers over such wide areas.
So it isn't a difference in believing in those layers that exist.
Not at all.
It's the difference of time, isn't it?
Correct. It's not a question of science versus the Bible. When we're talking about the flood paradigm and the conventional paradigm, we're actually talking about two different views of Earth history.
Those views really are different. Of course, I grew up being taught the conventional view with its long ages and slow, uniform changes. But what was the history of the world according to Genesis? Kurt Wise took me from one fascinating place to another, showing me evidence of fossil forests, explaining the rapid formation of coal, and talking about the complex design of biological systems. Everywhere we turned, he showed me something new about the Earth and its history. We ended up at the entrance to an old abandoned coal mine.
This is leftover remains of the Dayton Coal and Iron Company, built about 110 years ago.
Well, what's amazing is if you didn't know that history, and if you looked at these rocks, you would think they were very ancient. In fact, if we were in Greece, we might think they're thousands of years old.
It's hard to tell just looking at the structure itself.
Well, Kurt, then I need for you to do something, because I know that the conventional
paradigm looks back in Earth history, and it's a straight line, a lot of uniform processes and so forth. But the Genesis history is telling us that it's not that uniform.
Yeah, that's a good point. In 2 Peter chapter 3, it talks about people in the latter days saying, where's the promise of this coming? For all things continue as they were from the beginning of the creation. That concept that what you see in the present, what's happening right now, what's happening in the creek down below, what is happening in every place on the earth, is the way it's always been. It's always been for all of Earth history. The passage goes on to say, for this they are willingly ignorant. They're not just ignorant of these truths, they're purposely rejecting these truths. And it lists the creation and the flood. These are apparently events, according to the Bible, that aren't like the present.
Right.
And the neat thing is, that's what we see here. That cliff isn't actually in place. That cliff belongs about 1,000 feet up. It's slid down to its current location. That's a pretty big boulder.
That's huge. That's
okay,
massive.
Now what kind of process in the present slides blocks that big down? This thing continues for a mile. But inside those rocks are yet further evidence of an event before that that's even bigger, even more unlike the present. And then inside those rocks are also fossils of a time period that's very different than the present. So that, according to the claims of Scripture and according to my own experience, you can't use the present to judge the past, to understand the past. But if you go all the way back to the beginning, you realize that the Bible lays out what I would call epochs of Earth history.
Major periods of time.
Just different things happening during each of these epochs, that if you lived in any one of the other epochs, you would never understand the previous epoch, because it's so different. The first one is the creation itself. In 6 days, God created the entire universe. He created the planets and the stars, and he stretched out the universe with his outstretched arm. That's obviously not happening today. He's not creating planets. In fact, at the end of that passage, he says he ended his creation work. Then we move into what I call the Edenian epoch, the period of time when Adam and Eve are in the Garden of Eden. And it's very different than the present. We get the impression from that passage, for example, that Adam and Eve, if they had not sinned, would have lived forever. It's hard to even conceive of human beings living forever. So it's a different world, wildly different. How long it lasts, we don't know, but it suddenly terminated with Adam and Eve eating of the tree of the knowledge good and evil,
rebelling,
and God cursing the creation. He changed the rules in the universe. Now no longer is the sun going to be able to burn forever. No longer are we going to be able to live forever.
So it's hard for us to even imagine what that would be like, because we only see the laws are...
And we wouldn't have come to that conclusion if we didn't have the Word of God.
We didn't have this...
And that's what I think the Word of God has been given to us for. So we slide into the third epoch of time, what I call the antediluvian period, the period before the flood and after the fall of man. It's a world that's different than the present. It's got the same natural laws going on, but it's a different set of critters, different set of plants. It's a little bit warmer Earth. The continents are in different positions from what they are now. It looks significantly different.
Well, that's what we see in Peter, where it talks about that world being destroyed. So the flood was not just soaking everything. This was radical change, wasn't it?
Yeah, if we're right about what we've understood so far, we got continents moving, smashing together, creating mountains. Mountains are rising to tens of thousands of feet. You've got water washing across entire continents. We're ripping thousands of feet of sediment off of the old continents and then depositing thousands of feet of sediment on top of them again. We're looking at earthquakes of astonishing power.
So this change then from what you call the antediluvian epoch now into the post-flood.
Basically, the Earth has got to recover from a global flood. The atmosphere's got to recover, the geology, the rocks have to recover, plants and animals have to spread across the Earth. You got lots of water, humongous earthquake, humongous volcanoes, and more or less that period of recovery is a slow decrease in intensity and frequency of those things.
So would it be in that period that we would see the Ice Age, for example?
Yes, that's ironically, the Ice Age turns out to be, in our modeling, a consequence of the heating of the water during the flood. Water is evaporating off the oceans, that cools the oceans. The water is then moving over the continents and dropping enormous volumes of water. Now, in certain places, the rain's going to come down as snow, but coming down so rapidly and without break that it can't melt and accumulates into thick sequences of ice until they're miles thick. And then when the oceans had cooled enough that that rain generation system had stopped, then those glaciers then collapse under their own weight, melt back to the current position, and they're continuing to melt. You know, this thing, global warming, it's recovering, the Earth is still recovering from the flood.
So that was really a fairly tumultuous era right then, but then you have one final epoch.
So the modern epoch is you can study present processes and understand things fairly readily back to within a couple centuries of the flood.
And so that would lead one to think that these processes, if you take them all the way back...
Precisely.
Right.
You take the present processes and extend them into the back. And that's what 2 Peter says. That's the error people make. It's reasonable. Take the present and extend it into the past. Not unreasonable. So you need to go to the Bible to find out the necessary information to reconstruct it. And looking at it the other way, if you start from the Bible, you only get the beginning of the story.
Right.
God has given us the ability to read the rocks and fill in the rest of the story.
Yeah.
And we need to fully understand the flood, we start with the Bible, but then we go to the rocks. Speak to the rocks and they shall tell thee what has happened in the past.
Kurt made a good point. The Bible records historical events, but it doesn't explain how those events happened. That's what these scientists were doing. They were trying to interpret the evidence in light of biblical history. But Kurt said there was evidence inside the rocks. What was that evidence?
I love coming to natural history museums. For me, as a paleontologist, it's like the chance to go to a zoo. It's all the animals that used to live before the flood. It's like a chance to step back in time.
It is like a zoo, except they're not alive.
Right, and they don't smell, so that's pretty good. And the Natural History Museum isn't just about telling us what was there. It's also trying to give us a storyline, right? And we've got two possibilities. We've got these two paradigms between a naturalistic view and a biblical view. And all the natural history museums in the country, most of them around the world, all give you just one of those views, only giving you the naturalistic, old Earth view of the world. But these same data, this dinosaur, is able to be understood in an alternate paradigm. So when I'm thinking about these types of creatures, I'm thinking about a world that's right before the flood.
I mean, this is a real picture of a violent world.
Yeah. That's why God said, behold, the end of all flesh. It wasn't just mankind. Man and all of the animals over which we rule are judged at the time of the flood.
Well, Marcus, can you kind of give us an overall picture of the fossils and how all this stuff fits together?
Yeah. Fossils tend to be found in distinct layers where there are very, very large numbers that have been destroyed, untold billions. And so every time we see a layer of rock that's this thick, we're thinking about an event that probably took minutes to make, not thousands of years, minutes for just this one package of rock, sometimes even seconds, where these pulses of water from the flood are moving over the continents, grabbing ecosystems or dragging marine ones up from deeper in the ocean and pulling them onto land. And as one gets deposited and the waves come back, they start pulling and piling additional stuff on top of that. And it's a graveyard on top of a graveyard on top of a graveyard. It's the sort of thing that speaks to catastrophe, not the sort of thing where the fossil record is gradually accumulating bone by bone, shell by shell, little by little, over untold eons of time.
So you're saying that we have these marine fossils all over, even on mountains?
Yeah. You know, further back over in the museum, they've got sections with things like mosasaurs, these big swimming reptiles. Mosasaurs are globally distributed, and they're distributed on continents. So looking at these things, you're saying, what is it that has the power? What is it that has the capacity to take the marine world and throw it on top of the continents in such a violent and destructive manner? And the flood makes perfect sense for this.
When we were in the Grand Canyon, we saw that great unconformity.
Yeah.
And there were no fossils to speak of really below that. And then all of a sudden we start getting a lot. What does that say to you as a paleontologist?
Well, the great unconformity is telling me that there's some sort of massive erosion and shearing that's happening across the continent. And then once we start getting to those nice sedimentary rocks that have all the wonderful fossils in them, the pattern starts to emerge. The ecosystem that has the first animals in it shows up very suddenly. In conventional paleontology, they call this the Cambrian explosion. It's the first appearance of a wide diversity of different types of marine animals. All of a sudden, you have this complex and whole ecosystem that shows up basically out of nowhere. Now, that makes perfect sense from a creation and flood perspective because the flood is about destroying ecosystems. Whereas in an evolutionary view, these ecosystems are going to have to arise a little bit more gradually as organisms diversify and evolve and respond to one another in their environment. But that's not what you see. Instead, you see an explosion of life that is complex, whole. The ecosystem is integrated with one another. You can see where all the different organisms fit with respect to one another. And that's just the first time that that happens. Every time you move up in the geological column, in this fossil record, you start seeing snapshots of more and more ecosystems. You've got one ecosystem that's destroyed, and then you've got another one. It's got slightly different creatures. There's different interactions going on. And as the floodwaters move higher and higher, they're getting closer and closer to shore, destroying more and more organisms in the shoreline and eventually up onto land.
Yeah. So I think I see what you're saying here, and that is that the paradigm that we're all taught, that conventional paradigm, is trying to tell us that the fossil record is an evolutionary picture of life as it is developing, as opposed to the Genesis paradigm that's saying, no, all of that life, all the complexity of life already was there, and now we're looking at the graveyard of all that life.
Exactly.
Well, what are some of the other data that you're seeing that convinces you of this paradigm?
Sure. Well, one very curious situation with the fossil record, so thinking vertically about things, is not the hard parts of the animal, but the trackways. They're the footprints. This is a pattern that we see in several different groups where their footprints are first and their body parts are later. For the trilobites, for the amphibians, for the dinosaurs, the first time I find evidence of them in the fossil record, it's from trackways, not the hard parts. From an old Earth perspective, that's really weird and hard to grapple with because you have millions of years between the trackway production and ultimately the animal that made it. But that obviously doesn't make a whole lot of sense. Right? Because if there's trackways, there's animals, and those animals have bones and teeth and shells to them. Why aren't they fossilized? Instead, the pattern's telling us something different. There's no time between when somebody leaves a track and when somebody gets buried.
But the fact that those trackways are still there, that should tell us something as well, shouldn't it?
One, it tells us that the deposition or the placement of the next layer on top of them had to happen very, very quickly. Because, again, you go out onto a beach and you walk in the sand, your trackways are destroyed very, very quickly. But the fossil record is showing us something very different from today. This is death in a moment, right? This is death in an instant. And we're talking about a world that was complex, whole, integrated, and the flood is destroying that world sequentially and burying it in a vertical fashion. And so I think looking at the fossil record as a record of life is partly correct, but it's not about life's development. It's about life's attempt to survive an event that ultimately consumed all of them.
Well, that would make sense then, because when God was talking about destroying the earth with the flood, it wasn't just the destruction of human life, it was the destruction of all life. And so now the world we live in is, as you said, radically different than what that was before.
Yeah, when we look at the T-Rex, when we look at the mosasaurs, when we look at all these animals as ferocious carnivores, and they really are, I mean, they're terrifying, but that's not what they were initially created to be. And so these sharp teeth, these devastating claws, and the behaviors that go along with them all seem to be part of the curse. And part of that is genetic, part of it might also be just some modifications, but these organisms, by the time we see them, and this is important for us to remember when we come to a natural history museum, is you're not seeing the world at creation week. You're seeing the world as it existed at the flood. And that world was one that was filled with violence and was a pretty terrible place to be.
I realized that the billions of creatures buried in those layers are a silent testimony to God's global judgment. I decided I wanted to see one of those layers of fossils for myself. If the dinosaurs had died suddenly in the flood, wouldn't it be obvious?
What we're dealing with here, this is in the Lance Formation. This is a Upper Cretaceous sedimentary deposit. And what we have here is what's called a bone bed. It's an accumulation of bones that's about 1 meter thick, a little less than 1 meter. And in this meter, we find the bones present as a graded bed with little bones at the top and bigger bones at the bottom. And you can see here, looks like Kirline is working on another vertebra here. This is a cervical vertebra of a duck-billed dinosaur. This is where the spinal cord goes, right there. When I look at these bones in the quarry, I often think of them as being inside the animal alive, and just imagine what it's like to be seeing these bones for the first time. So this is just full of bones, and it's not like we have to go looking for where the bones are. We just have to sit down and start digging.
What is mainly different about the sites that you're digging here as opposed to what we would say a general dinosaur dig somewhere?
Well, there are dinosaurs found all over the world, but this particular site is unique in that it's probably one of the largest collections of bones in the world. And there are the remains of I'd say between 5,000 and 10,000 animals, each 20 to 40 feet long in this deposit. These are big animals, and there are a lot of them.
Let's step back for just a second. Okay, so we had a duck-bill dinosaur roaming around the Earth, and all of a sudden it dies. Would it become a fossil?
Fossilization requires very special circumstances. Normally, we know, for example, if a coyote dies out in the desert, its body is soon gone. Yet these bones are all perfectly preserved. They have never been subjected to weather. They are just all there. Today it would be very difficult to imagine how you could do that.
To some extent, we would really say that to find a fossil is rare. Even though we have many, many fossils, in terms of things that die, it's rare if they become fossilized.
It is rare. It requires special circumstances, not the least of which is rapid burial. These animals had to die, and then their carcasses had to have time to rot. So we're talking days or weeks or months, during which time the bones and tissues were either eaten away or rotted away. And then the bones that remained were deposited instantaneously in this environment because they're in a graded bed with big bones at the bottom and little bones at the top. And you can see that here. The big bones are all down at the bottom. And when they start digging up here, they start to find smaller bones. So that condition requires a sorting process that can only take place during a catastrophic emplacement.
So when we look at the dinosaur fossils, rather than looking at them from the standpoint of we have early dinosaurs, then middle dinosaurs, then later dinosaurs, you're looking at from the perspective that all those dinosaurs were in existence. They were all living, and then there was this huge catastrophe that brought them to an end.
The dinosaurs are already dinosaurs when they first appear. They look just like anyone would think a dinosaur looked. And this is an enigma for those who believe in the evolution of the dinosaurs.
But we hear a lot about transitional forms. What's the real story there?
Scientists have been able to lay out some forms they think are transitional. And some of them are very interesting, some even challenging. But they are the exceptions to the rule. The rule is there are no transitional fossils. And what we find in the fossil record, and contra to Darwin's hopes, this is the rule, is that a form exists in the fossil record, it basically stays unchanged, and it disappears from the fossil record without having been changed. That's got to mean something besides evolution, because we don't ever see changes from this form into this form in the rocks themselves. So it's coming from somewhere else. It's a paradigm that's being imposed on the data rather than the data providing the paradigm. So I think it's very easy for me to be a creationist just based on my understanding of the complexity of life forms. And when we look at the fossil record, we can see that complexity is all there from the beginning, and this begs the question of where did all this complexity come from? It's one thing to have faith. I have faith that God was the creator, but that's substantiated by what I see around me. To say I have faith that evolution produced this when I can't even see how it could have happened, that's blind faith.
That's a leap in the dark.
That's a leap in the dark.
It seemed that everywhere I looked, there was a growing body of evidence that fit the historical record of Genesis. It wasn't just one thing, it was many things pointing in the same direction. When I was with Art, he told me about some recent discoveries of material inside dinosaur bones. So I traveled to a lab in Arizona to talk to a scientist who is doing some of that research himself.
This is a fragment of a Triceratops horn. When we pulled it out of the ground, it fragmented, and then, of course, we've had to continue to fragment it in order to do analysis of it. In 2012, the Creation Research Society sponsored Mark Armitage and I to go to the Hell Creek Formation in Montana, which is a very popular place for finding dinosaur bones, and we instead dug out a almost 4-foot-long Triceratops brow horn. Now, it's just in crumbled pieces now, so we can't really, put it together and show you a horn. But yeah, you have to recognize that pieces such as this, we have found tissue with cells.
Oh, that's amazing.
And potentially proteins such as collagen. It's so difficult to understand how you could have this material still in a dinosaur fossil that is supposed to be 65, 75, 80 million years of age, because tissue, cells, proteins break down. They're not concrete, they don't just exist for eons of time, they break down. And in fact, they tend to break down fairly quickly depending upon the conditions. And certainly in Hell Creek, the conditions would be warm up, cool down, warm up, cool down. And any biochemist can tell you that is the fastest way to destroy material. It's difficult enough to envision it surviving for 4,000 or 5,000 years, but 60 million years, 70 million years, see, that really becomes very difficult to make any kind of biochemical basis for how it could have survived.
Okay, so once you find a sample like this, what do you do next?
So what we do is we soak the fossil material in a solution called EDTA. And what you'll have after you dissolve the fossil is the tissue will be remaining because the EDTA won't dissolve the tissue. So then I'll bring this over to what we call a dissection microscope. This is, in essence, dissolved Triceratops horn magnified. And so you can see what it looks like, just kind of little pieces of rock.
Well, Kevin, what did you find then when you were looking at the sample and you actually found some tissue?
Okay, here's what we found. This is actually Triceratops tissue. It's stretchable, it's pliable, it's not an impression of the soft parts of the dinosaur. This is truly soft, it is squishy, it is stretchable, it is tissue.
That blows your mind, huh?
Absolutely. And if you look at them then at a closer magnification, what we see then, this is using scanning electron microscopy, you see the extreme detail of the cells. See, in that picture, and this picture, and particularly like look at this picture, we would not begin to expect to see such enormous and elaborate detail. I mean, these structures are incredibly small. You know, this is our 20 micron bar here. See how small these structures are, still intact. It would take very little to break those. So at best, you would expect that all that would have broken off and been long gone.
So that has to have shaken up the scientific community. What's been the response of all of this?
The initial response, when Dr. Schweitzer first published her work, which is what became very popularized in 2005, it generated a lot of response. And so initially some of the reaction was rejection. Oh, it's contamination. You know, that's not really dinosaur. It's bacteria, because bacteria can look kind of strange sometimes. So you had a lot of proposals of what it could be. And to her credit, Dr. Schweitzer did more work. They began to find protein. You break open some of these cells. You look at the matrix these cells are attached to, and they're protein.
Okay, so once that is understood,
yes,
then what happens? Now this is shaking it up, I guess.
That becomes part of the controversy, because clearly you're now faced with how could you explain the survival of this, the pristine survival of this, not only for so long, but in very unpristine conditions. And so then the controversy has been, how do you explain it? And if you read some of the literature, there's almost like desperation because they recognized what the implications of this could be. Now, some people would claim, well, it means nothing because we know how old they are, and therefore it just means it survived somehow, big deal. But how do you know how old they are? Well, you use methods, supposed methods of dating. Well, this is a method of dating. The tissue itself can't be discounted as part of a method of dating. So why do you say that doesn't count, but this does count? Well, it's all the paradigm drives your conclusions. The paradigm is it has to be old. Therefore, methods that give us an old fossil are what we choose. Something that doesn't give us an old fossil, like tissue, we have to reject or explain away.
At least to me, and of course I'm not a microbiologist, but I think most people would say, well, that just seems reasonable to think that maybe these are not that old.
Clearly, this is in violation of the dating process. It challenges the entire dating process. If the fossils of dinosaurs have been dated incorrectly, which I would say this is clear evidence they have, then it's very likely the fossils of any organism have been dated incorrectly, and therefore then the geologic ages themselves are incorrect.
What you're saying is that if you pull out the notion of a long period of time, you're pulling out a major foundation for the conventional paradigm.
Absolutely. In fact, time is the critical component for evolution. If you're going to say that a simple cellular system became a multicellular system that then became fish, and the fish then jumped up on land and grew legs and started breathing air, and then that creature grew feathers and wings and started flying. So if you give us time, we'll claim to account for all of this massive change of organisms, but we got to have the time.
Everything seemed to come back to the question of time. I remembered Andrew saying that Charles Darwin accepted millions of years first, then fit his theory of evolution to that assumption. But why is time such an important element to evolution? Rob Carter is a marine biologist, so he took me scuba diving to get a glimpse of a world most people don't see. His specialty was coral, and he knew a lot about the incredible creatures that inhabit the reefs around St. Thomas.
Oh man, we got the sharks here. I mean, just look how they move. I mean, it's almost like effortlessly glide along. I wish I could swim like that.
Engineers wish we could make boats like that.
Yeah.
Submarines that could move as efficiently as a shark. We can't quite do it.
So from your perspective as a marine biologist, and I know that you've studied the whole area of genetics a lot.
Yes.
When people talk about evolution, what is it?
How do you define evolution? The word means change over time. But I believe in change over time, but I'm not an evolutionist. So how does one figure this out? Really, evolution is a belief that enough change over time, over enough time, can lead to the common ancestry of all species on Earth.
All right.
So that's the part I reject. Of course species change. I mean, look at these sharks here. We have several different species of sharks. When God created, he put into those organisms the ability to change, to adapt, to respond dynamically to the environment. But they're still sharks. And when we look at the fossil record, they're still sharks. You know, people have heard the phrase, the missing link. Right. And they usually think of between man and monkeys. No, there's missing links between almost every major group of animal and almost every other major group of animal and plant, even bacteria, throughout the entire fossil record, which indicates very strongly that these are actually different creations.
So we don't get one kind becoming another kind?
No. Evolutionary theory requires that small, random changes can explain everything we see. But it can't.
And why can't it?
Because life is so complex that small changes can't explain it. Just like you can't take a computer operating system and look at it and say, oh yeah, this is built up one digit at a time over any length of time. No, it took an intelligent person to sit down and put it together.
Well, I can guarantee you, as one who was in that world, that if anyone in the area of computer science were to say, if we just randomly change some things in this operating system, it'll get better. I mean, no one would agree with that.
No, we're not going to get the shark to evolve into a bird. That the number of changes and the types of changes are not something that you can do one change at a time. This is a sea urchin.
It looks spiny.
It's pointy. You got to be careful.
Am I going to get stuck if I touch it?
No. He's pointy, but...
Oh, my goodness, they're moving.
Yes, they're moving. And in between the spines are little tube feet, especially on the bottom. Oh, look at that movement. So he walks with his spines, but he's little tube feet in here, and that's what he uses to grab onto things. But looking carefully, there's 1, 2, 3, 4, 5, 6, 7. There are actually 10 radial parts to this animal. Actually, the starfish is his cousin.
Are you serious? You can't be serious.
Absolutely. The starfish here is also an echinoderm, but notice he has 5-fold symmetry instead of 10.
Yeah?
This starfish does. On the bottom, look. We see the spines, we see the tube feet. His mouth is in the center there.
So there is some similarity here, even though externally it looks a lot different.
A lot different. Actually, you want to see something that looks a lot different?
Sure.
Which is a cousin to the starfish and the sea urchin?
All right. It almost looks like a rock.
Yes. I got to be careful. He's squirting on me. This is a sea cucumber. He has spines. He has 2 feet.
Oh, my goodness.
You would never know it until you studied really hard that this also is an echinoderm. He's not very happy being out of the water, so let me put him back in.
Yeah, so these are all related, even though they look very, very different.
Related in their creation. Not in an evolutionary sense, but our creator took this phylum of life, the echinoderms, and created this and this and this on a similar pattern. And that's what we see across the entire realm of life, similarities and differences.
So what makes them different?
Well, genetically, they share most of their genes in common. But there are developmental genes, they're called Hox genes, that set up these patterns in the animal as it develops. They develop from a single cell. In one of them, they set up a 5-fold symmetry. Another, they set up a 10-fold symmetry. Another one, they make this long, skinny animal. They control the development of the embryo in these amazing ways.
So what you're saying, when we look at this from a molecular or genetic perspective, what we're finding is really a fascinating design in all of this.
Absolutely.
But what we've heard in the conventional paradigm, the conventional story tells us that it's those random changes that has brought about all of this.
Sure. Back in the 1800s, when life was simple, when they didn't know what was happening inside the cell, they didn't know how complex genetics was, you could imagine all sorts of things. But now that we know what actually happens behind the scenes, the story gets a lot more complicated. You see, I like to say the genome is 4-dimensional. Well, we have a 1-dimensional string called DNA. And if you want to draw that out, you'd have to write all the letters of DNA out on all 3 billion of them. And then you have to draw lines or arrows from one part to another part, because this part turns this part off, this part interferes with this part enhances this. It's this huge 2-dimensional interaction network. And that's where you have a 2-dimensional genome.
I mean, let me stop you for a second, because this is really amazing to think about this, because I think, in terms of a computer program, that it's fairly static. I mean, the instructions are there. But you're talking about a program that is reprogramming itself. It's modifying its own instructions.
Oh, wait till I get to the 4th dimension.
Oh, okay.
Because of the 3rd dimension first. The information in that 1st dimension, that linear string, has to be organized in such a way that when it falls into the 3rd dimension, it still works.
Oh, that's amazing.
Genes that are used together are next to each other in 3D space.
Are you saying that once this thing gets folded up, it's almost like we have a new set of instructions?
Yes, a new level of information.
Unbelievable.
That whoever programmed that first level needed to understand what was going to happen, have it work in the third level.
You said there's another dimension even.
Oh yeah, the fourth dimension is time.
And how does that work?
The genome changes shape over time. Maybe you eat something that's bad for you, and your liver says, I can get rid of that toxin. Now, the chromosomes in the liver will change shape, expose that new protein gene, make copies of it, build a brand new protein that can kill off that toxin, and when it's not needed anymore, they'll change shape again and fold back.
Oh my goodness.
Dynamic programming. All 3 levels change in the 4th level, time.
Rob, that's so far beyond anything that we know, even in our most complex software systems, that it's almost beyond imagination to think that someone would look at that and say it all happened by chance.
Yes, and it only brings glory to God.
It does.
You can't build something like that up one thing at a time. You need it to function. In all this interlocking 4-dimensional complexity, it's not something you can do one letter at a time with natural selection.
Mm-hmm. It all has to be there.
Yeah, in the same way when we talked about the environment out here on the coral reef, if you don't have all these interlocking pieces of that puzzle, you don't have that ecology. The system will come crashing down if you just remove a couple of very important factors that are there. They have to be together or it doesn't happen.
So not only did we have this interdependency, this mutualism, so to speak, down at the genetic level, now we even make it more complex by saying there is that same mutualism at the higher level as well.
Yes. In fact, the entire world has a mutualism.
It's impossible to think that all of this could have happened just by a series of slow processes over billions of years.
That's exactly what I'm saying.
It's clear that the world we live in is incredibly interdependent, from the smallest biological system to the largest ecosystem. There are complex mutual relationships everywhere. I realize that creation in 6 days makes the most sense from an engineering perspective. You need everything working together at the same time for everything to function properly. And that's exactly how Genesis says God created it. Rob also said God created animals with the ability to change and adapt to their environments. Is it possible this ability to change has been mistaken for evolution? As Todd Wood and I walked through the zoo, we saw incredible beauty and amazing design wherever we looked. I noticed the great diversity between some animals, as well as the remarkable similarity of others.
As a biologist, what do you see when you see all of these creatures?
Yeah, when I look at this, look at these lions specifically, I'm seeing cats myself. And all the other cats they have here at the zoo, they all have this underlying catness to them that's really apparent. It's really apparent when they start playing, right? You're seeing them playing with some sort of ball or something, and
they're just like a cat.
They look like a cat. You know, scientists would put that into a family called Felidae. And I would understand the felids to be representatives of a single created kind. So the continuity, the similarity there is so significant that I'd say, yeah, these guys have all descended from a single pair of critters that was on the ark, and that eventually generated all the different sorts of cats that we have today.
So rather than just a random accident, it appears as if all of these different species are coming from a really elaborate design.
Oh, absolutely. And it's not just a design like God, you know, designed and created the lion. It's God created something that could make a lion. So it's more like, you know, a multi-tool or a Swiss Army knife where you got all these pieces that you can just pop out whenever you need them, but it's all just one thing.
So give me some other examples of created kinds.
Yeah, so you've got the grizzlies and the polar bear. Those are all members of the bear kind. You've got ducks, swans, and geese. The thing about the dog kind is really interesting. So you take just this wolf-like creature, and we can breed in only a few hundred years many different breeds.
Well, Todd, that's kind of fascinating now to think about what God was doing when he was bringing two of every kind. What do you think was going on there?
Oh, yeah. I mean, he doesn't have to bring every little variety onto the ark. So when you actually do the calculations, and okay, so we don't know exactly how many created kinds there were on the ark, but maybe a couple thousand, and they're small. Most animals are quite small, so you have room to spare, literally room to spare. And all of that diversity that we have today is built into those two of every kind.
Well, Todd, we're looking at the zebras, and they're all unique, and yet all of these creatures are just so much complexity and diversity. How does the standard story, the conventional paradigm, explain all of that?
Well, they would use evolution, right? So millions of years, random variations, all things that are alive now, that cactus, that zebra, the grass here, it's all related. We all go back to a common ancestor that lived billions of years ago. And through the process of mutation and genetic variation and natural selection, that's where we get the stuff that we have today.
So, natural selection, what is it? Does it have the kind of creative potential that we need for all of this?
Natural selection is basically all about killing off things that aren't fit for the environment. So if you're a finch in the Galapagos and you have a really tiny beak and the only food available to you is really big, hard seeds, you're going to die. And that's exactly what we observe. And so we can watch over the generations as the beak size and finches change in the Galapagos. But they're still finches, they're still birds. The notion that natural selection can generate all of the diversity we see, that's not been demonstrated. What we find most often with natural selection is that natural selection does a lot of fine-tuning. So right over here, we've got these oryxes, right? Beautiful creatures and very, very pale colors. The wild range of the oryx is right on the southern end of the Sahara Desert. And so you can see, yeah, their coloration makes sense. If you get a really dark-colored one, that's going to be really easy for predators to find. And so they end up being these really beautiful light colors. And that's an example of where selection would take a variation and turn it into an adaptation.
And that brings us back to the notion that a really exquisite design in the beginning
I think so. Absolutely.
Has provided these creatures with the ability to survive and to change for their benefit.
Absolutely. So the ability to be able to change your coloration like that, to be able to fit an environment, that's got to be built into the system before it starts. Now, don't get me wrong. I mean, natural selection and random variation can do amazing things. I mean, it's pretty astonishing the kinds of changes that we can see, but we don't see one kind changing into another. All we see are variations that happen within a created kind. So there's a felid tree, which has all the cats on it. There's the canid tree, which has all the dogs on it. There's the ursid tree, which has all the bears on it. There's the equid tree with all the horses on it. Each individual created kind, then, has its own individual tree, so that you end up with something like an orchard or a forest.
As a scientist, it seems what you're saying is that the Genesis paradigm answers all of this data better.
Ultimately, I think it does, because it embraces both similarity and difference. Now, as we've already said, there's lots of questions that are still out there. But I'm pretty confident, given what our paradigm can explain, I'm very confident that those answers are going to be found.
After we left the zebras, we made our way to the gorillas. Todd wanted to talk about the question of human evolution.
Todd, we see it all the time, a new discovery, new skulls, new skeletons that supposedly solidify this whole link.
Yeah.
What do you see there?
Absolutely. Well, I got some right here in my bag.
Ooh, a skull.
So this guy is a Neanderthal, very, very low forehead. So we have really tall foreheads. The face, the mid-face has been pulled out. But at the same time, well, it looks very human. So that's Neanderthal. Okay. You want to hold that one for me?
Yeah.
Okay. We have others that are very different.
Oh, yeah.
Now, this one is Australopithecus africanus. So you can see really no forehead at all. It just slopes right back. Very, very small brain case. Muzzle sticks way out, so the face is sloped forward. What do you do with this stuff? I mean, there's many more that we could show, many more pictures, many more skulls, and you can see, looking at them together, they're really, there's a lot of difference there.
Yeah.
Well, here's the thing. So all that created kind stuff that we already talked about, I can show again and again and again with multiple studies that I can find a discontinuity between humans and non-humans. So this thing lands on the human side. This Neanderthal here, it's one of us. This thing is not. It is different. But this would be just another one of those varieties of living things that God made in the beginning and that survived the flood aboard the ark.
So when we look at Neanderthal man, we're looking at a human, but it's a human that, just like we find in dogs, we have a lot of variety of dogs.
We got a lot of variety of people. So even looking back here at the gorilla, we can see the obvious differences between us and him, not the least of which is that he's in there and we can go home when we're done.
And so those differences are really huge, aren't they?
Yeah, absolutely. The image of God entails this idea of being God's representative here on this earth. Part of that, then, is having dominion and having authority, spiritual quality that we have, that we don't share with animals like that.
Yeah.
It's obvious we're different from the rest of creation because we're made in God's image. We're the only ones to create zoos so we can see the beauty of God's animals. And we're unique in tracking time and wanting to know our own history. But where does our concept of time come from? It was a beautiful night. Danny took me far outside the city and kept me up very late in order to show me something I will never forget.
Oh, my goodness. Now you're going to make me buy a telescope.
You know, we have some purposes given for the stars in Genesis 1:14-19. It's a day 4 creation account. It mentions the stars and other heavenly bodies to mark time, to rule over the night, to be for signs, seasons, festivals, and so forth. People have been using the stars for marking passage of time. The patterns repeat every night. They repeat every year. They come back in their season. There's a lot of regularity going on here.
What about the design of the sun and the moon?
Well, there are a couple of things I can talk about. On rare occasions, the moon passes between us and the sun. Doesn't happen very often. And when that happens, the moon just barely covers the sun up. If the moon were a little smaller or a little farther away, it wouldn't do it at all. If it were larger or closer to us, it would be grossly over total. And so these eclipses are spectacular and rare, and this is the only planet on which it matters, and it's the only planet on which it happens. And you've got to think either just that's the way the world is for no apparent reason, or the world is that way for a purpose and design. And to me, that speaks of creation. Okay, high overhead here we have the Great Square of Pegasus. It's this big rectangle. Now, coming off of Pegasus is a little fuzzy spot right there. Do you see that?
Yes.
That's the Andromeda Galaxy. That is the most distant object that you can see with the naked eye. It's we think a little over 2 million light years away, and it contains a couple 100 billion stars.
Wow. Okay, Danny, that brings me to a big question, and a big question in a lot of people's minds. If we have stars that are that far away, millions of light years away, and if the Earth is young, as we believe, then how in the world can the starlight be here?
Yeah, we call this the light travel time problem, and I'll try to phrase it for you a little differently. We believe that the creation is only thousands of years old, say 6,000 years, 7,000 years, something like that. And I've just pointed out something to you that we think is 2 million light years away from us. I think those distances are reasonably correct. And we creationists need to answer this question, and we've offered several different solutions to that. I'll discuss with you my solution on this. Several things jump out at me in the creation account. One, there was a lot of process going on, very rapid process, but still process. If you look at the day 3 account, it talks about plants rising up out of the ground. It says, let the earth bring forth these plants, and the earth brought forth. I think if you would have been there, it would have looked like a time-lapse movie. Growth that might take normally decades taking place in a matter of minutes or hours at the most. Normal growth abnormally fast. I believe you can interpret one day of creation in terms of another day. So I turn to the day 4 account. Not much information is given there, but I think God also rapidly made the stars and other astronomical bodies. And then in order for them to fulfill their function to be seen, he had to rapidly bring forth that light, just as he brought plants and matured them quickly. He had to bring that light here. I'm suggesting when we actually look at these objects, like the Andromeda Galaxy we saw a few minutes ago, we're looking at light that actually left that object.
Yes.
So I think there's a rapid maturing took place.
Danny, are there some other things that you see that would point to a young universe?
I think so. For instance, spiral galaxies. The Andromeda Galaxy we talked about is a spiral galaxy. Our own is. And the inside of the galaxies should spin faster than the outside of the galaxy. So after a few rotations, you ought to wind up or smear out those spiral patterns. They ought to disappear after a few rotations. Now, most astronomers think that spiral galaxies are 10 billion years old. So why do we still see spiral patterns? You shouldn't see those.
Right.
And it's been long recognized as a problem. But also, if we look at the outer planets of the solar system, the gas giants, they all have rings. And we also know that these things are changing. They're wiping out. They've actually documented changes that have taken place within the ring system. You have all these gravitational tugs from the other satellites orbiting around. So these ring systems are fairly young. It doesn't prove the solar system is young, but it proves that these ring systems are young. And that's interesting.
We've mentioned a lot of theories about the spirals and so forth. It brings us to what most people see as the big theory concerning cosmology and the universe, and that's the Big Bang. How do you see that? Is it holding up over time?
I don't think so. I think it's getting some problems. So much so that more than a dozen years ago, I think in the New Scientist magazine, there was an open letter protesting the Big Bang Theory, and it's had hundreds of signatories since. And most of the people signing it are atheists. They're not even creationists. So this idea that the Big Bang model is universally accepted is not true. There are many people out there, well-known people, very famous physics and astronomy people, that have real problems with the Big Bang. And I don't see any way that you can reconcile Big Bang with the Bible, though a lot of people seem to think that you can. I think the temptation they have there is to try to interpret Scripture in terms of the current cosmological thinking. That's nothing new. That's happened before, as it's turned out, with disastrous results. So I think when you look at the history of science, the way we've discarded theories over time, you've had theories that were supposedly beyond dispute, and then later on discarded. When you see that lesson from history and then you want to wed Genesis, you want to interpret Genesis in terms of the ruling paradigm, I think you need to be very careful.
I realized Danny was reorienting our perspective. We need to interpret the universe in terms of Genesis, not the other way around. And Genesis tells us that God created the sun, moon, and stars to be a magnificent clock to track the passage of time. Even the ancients built towers to follow the stars. But what does Genesis say about those people and the languages they spoke? Doug took me to one of the best archaeological museums in the world to show me some of the unique artifacts that relate to Genesis.
Well, the events of the Bible are unfolded in the ancient Near East, so all of these lands are extremely important to understanding how and what took place in the biblical text.
So this picks up these events we've been looking at in Genesis, from creation and the flood, and now we're to the dispersion of mankind out of Noah and his family.
Exactly. And the dispersion would have taken place somewhere in this mountain range to the northwest of Mesopotamia. And what we see in the biblical text in the narrative is that a number of people have migrated down to southern Mesopotamia, the land of Shinar, and moved toward the process of urbanization, city living.
And that's the famous Tower of Babel.
Absolutely.
Do we know where that is?
There are about 7 or 8 Babels, cities of Babel, in the ancient area of Mesopotamia. And so one at a time, I've studied all of those areas and found only one that meets all the criteria of the famous site of the Tower of Babel. And that is the site of Eridu, which is in southeastern Mesopotamia. We have signs of the expansion to the north, to the south, to the east, to the west, all the way as far as Egypt.
And when you say evidence, that is the artifacts that we find in these archaeological digs?
Exactly. There's an enormous amount and very specific kinds of material culture that attest to this expansion of people that I'm connecting to the post-Babel dispersion. Here are the beveled rim bowls, these two, which is that Rimken brick that we see up there, and those two spouted jars. All of these diagnostic forms of pottery and material culture, they're found throughout the Near East. The Bible describes an event that's not just the confusion of language, but it's the dispersing of people far from that city. And because we see language or the written expression of language just pop up out of nowhere, and then different languages being represented through cuneiform script or through hieroglyphic script or other means. So you do not have a universal plan that's followed among all of the languages. You see great diversity in the forms of grammar from language to language, even in ancient languages.
It seems then that the event recorded in Genesis about the Tower of Babel, that's a very, very critical event for archaeology.
It is. So all of this fits perfectly with what we would see as the biblical account of how languages took place. It's really the only way of explaining this. So the integrity of biblical history ultimately is justified by the expression of these languages.
Now, most of us think today of a tower, the kinds of things we see in big cities, big straight walls. Is that what they were building?
Well, essentially, it's a variation of a pyramid. And there were 4 sides to it and several stairways that would go up to the top. At Eridu, we have a temple that existed in 18 different phases. And in every phase, it grew in its size and its complexity. And that final temple, that final phase of the temple, it was abandoned immediately, right at the time of the late Uruk expansion. Catacorner to the temple was an absolutely enormous platform.
Do you think that could be the foundation of the Tower of Babel?
Absolutely, and I would suggest to you that this late Uruk expansion, where this technology began, was something that spread with the people. We find forms of these ziggurats all around the globe. We find them in China, we find them in India, we find them in various parts of the Americas. We find them all over.
Well, obviously we have evidence here of civilization and people beginning to gather together in communities, even cities. Do we have any other evidence of that?
Absolutely. We can move forward to the time of Abraham because we know that Abraham lived at the site of Ur, which was also in southern Mesopotamia, at the end of the 3rd millennium BC.
That brings us to the end of Genesis chapter 11.
Exactly. In fact, you see some pottery, some cuneiform tablets, all dating to the period of the 3rd dynasty of Ur.
It's amazing just as we're sitting here thinking about that, thinking about Abraham and that this represents the culture and the civilization that he lived in. It's a great tie to that record in Genesis 4.
It is fascinating, and it gives you a feeling of putting your hands around the events that go on in the biblical text.
When I look back through history, I realized each of these cultures had been impacted by the events recorded in Genesis. But what is the importance of Genesis to us today? George Grant wanted to meet me at a garden near his home. He said it was a good reminder of where our history began.
So there's something significant about the Genesis text in which Adam and Eve are then placed into a garden to tend it. That's more than just a story.
It's much more than just a story. One of the things that you see in Genesis chapter 1 is the structure for time. The universe is created for a 24-hour day. And so everything from the way our sleep cycles and the way our work cycles work all come from that definitive historical account there. When we get to Genesis chapter 2, we start to see the meaning and purpose of man. Of course, in Genesis chapter 3, we see the disruption of everything by the fall.
And the implications of an historical fall, an actual man and an actual woman who actually yielded to actual sin, have then implications all through the rest of the Bible. If you remove a literal Adam and Eve, that changes the whole shape of what history is and how history is remembered.
Is that because when we pull an Adam and Eve out of a historical record, we can then pretty much make up what we think about man and marriage and even sexuality?
Absolutely. The Apostle Paul understood the events of the early chapters of Genesis as formative, not only for our understanding of history, but for relationships between men and women and their children, the character and nature of marriage, rightness and wrongness in moral relations, including sexuality. All of that is assumed from those early chapters of Genesis, oftentimes quoting the passages verbatim.
It seems that even Peter is taking that event of the flood, for example, as a historical event and laying it in the context of what he's pointing to, a judgment that will come. So even judgment is a part of understanding that historical record.
You cut things off from history and you lose sight of the meaning of all of it.
I think most Christians, when we talk about, for example, the life of Christ, those are understood to be historical accounts. Right. Why is it that when we look at the account in Genesis, that we have a tendency not to want to do that?
We have a tendency not to do it because we're constantly exhorted to not see it that way.
From the culture around us?
The culture around us, from theologians, modern theologians who are trying to somehow, in their minds, fit the truths of Scripture with the so-called discoveries of science, which, if you know anything about the history of science, you know is an incredibly unreliable path. So we're constantly bombarded with this message that we have to adjust our view.
But I think there are a lot of Christians who have a sense that the historicity of Genesis is just not that important to their Christianity.
I think we've been sold a bill of goods on that. When you somehow make those chapters a different category altogether and non-historical, what are you doing to all of the rest of the Bible? The Bible that assumes that it's true, the Bible that treats it as historically true, the Bible that refers back to all of the characters that are there. Does that then negate the whole of the Bible? Well, yes. And that's exactly what the strategy was of the higher critics in the 18th and 19th centuries. They knew if you could somehow attack the first 3 or the first 11 chapters of Genesis, you've done away with the whole thing.
Well, George, all of this brings us back then to the notion that the history that's recorded in Genesis, or any true history at all, is critical for us in terms of understanding what's going on around us.
Yeah, in fact, it reminds us of how important history is in anchoring all of the other human disciplines. It is history that helps to inform science so that science can begin its journey of discovery in the world. So what history does is it tells us what happened. Then what science attempts to do is it asks the question, well, how did it happen? And then it begins to explore the how, the mechanics, the structures that were present in those events. If you try and reverse that, if you try and make science saying what actually happened, then you wind up having a worldview that is constantly shifting where nothing is certain. And moral relativism is the necessary outcome.
And God has given us that bedrock. He's given us that foundation in that historical record.
He's given it to us in that historical record, going all the way back to Genesis chapter 1 and the garden.
In the end, I suppose we always return home. And for me, home is Colorado. I always think more clearly when I'm out in the beauty of God's creation. We've been a lot of places and seen a lot of things, but considering everything together, it's clear that nothing in the world makes sense except in the light of Genesis.
I love being in the mountains, especially ones like these. They help give us a good perspective, help us realize that we're small and finite and vulnerable. They humble us. And we need to be humble because we have a tendency to base our ideas on our own small set of experiences. That's why the wisdom of the ages has told us over and over again to know history. Everything that we have done up to this point has looked at the evidence that shows us that the Word of God, the history that has been laid down for us in Genesis, is true. God created the world in 6 days. There is a real Adam, a real Eve. There is a real fall. There was a real flood that destroyed the world and produced all of this. It is glorious, but it represents the judgment of God. Everything supports what God has told us. Genesis is history, true history.